Hello and welcome back to another video lecture. In this video lecture, I will teach you how to test syllogisms and also Sorites for validity using the three Venn diagram technique. Now, it is very important to understand that when we use the three Venn diagram technique, we do it in accordance with the modern interpretation. If you don't understand or don't know what I'm referring to, I recommend watching my previous videos where I explain the difference between the traditional and the modern interpretation of logic. That would be the video where I explain the traditional square of opposition and the modern square of opposition. But essentially, to tell you in one sentence, essentially the difference between the modern and the traditional is that in the traditional interpretation, the universal statements, all SRP and no SRP, contain what is called an assumption, an existential assumption. In other words, the universal statements state that there exist the members of the subject category, whereas the modern interpretation does not make that assumption. And in practical terms, this means that by using the modern interpretation, we do not draw an X inside our Venn diagrams. Now, let's start with the syllogism AEE3. So first of all, we start by writing out the syllogism. Since this is an AEE3, what you want to do is to consider the premises and to consider the figure, the syllogism, which is number 3. Now, figure 3, if you recall from my previous video, means that the middle term is going to occur in the as the subject of the major premise and also the subject of the minor premise. So it's going to look like this. All M are P, no M are S, and the conclusion, no SRP. Once you have written out the syllogism, it's ready to test it. How do we test it? Well, first of all, you need to have three Venn diagrams. And you have to overlap the diagrams, the three circles, in such a way as to create a symmetrical figure, like the one that you see on the screen. Now, the next thing that you want to do is to label each circle. It is not important which one is S and which one is P. For example, in my screen right now, you see that the top left circle is S, and the right is P, and M is on the bottom. But you could have M on top, M on the bottom, and M on the right or left. Any term, it doesn't matter, as long as you decide which circle is which, and you keep it consistent. Now, at this point, once you have the three Venn diagrams overlapped, and you have labeled each circle. Then you proceed to diagram each premise. Warning: do not diagram the conclusion. The conclusion is what we are trying to determine. So you do not touch the conclusion. What you do is that you diagram only the first two premises. The only two premises. Now, what do I mean by diagram the premises? Well, if you recall, each categorical statement is represented by a specific diagram using Venn diagrams. And if you don't remember what they look like, just go back to my previous video where I explain what they look like. So what you want to do is to create the diagram that looks like the statement, and diagram and plug it into the three Venn diagram shape. So, for example, the first premise is an A form, all MRP. Consequently, as you recall from the previous video, in order for me to diagram exactly what the premise is asking for, that all MRP, you have to focus on the circle M and the circle P. And as you recall, you have to shade logical area 1. And by shading logical area 1, which is this one, you diagram exactly that, all MRP. Next, you diagram the second premise. Now, the second premise is an E form, so it's a universal negative, no MRS. Consequently, in order to diagram this, you have to focus on these two circles, S and M. And you have to shade logical area 2, which is the area that is right in between S and M. The area that looks like an I-shaped area. See? Okay. Now what? Now your diagram looks like this. There's a lot of shading here and there. Now the question is whether the conclusion, no SRP, as a result of my diagramming the premises, shows up. So if the conclusion shows up as a result, then the diagram, well, the syllogism is valid. But if the conclusion is not diagrammed as a result, then the syllogism is invalid. So let's see. Notice that the unshaded half of logical area 2 between S and P. But that's exactly what we need to be shaded, because remember that the correct answer, the correct conclusion, will be diagrammed only if the area 2 is completely shaded, like such. But as you can see, between S and P, area 2 is not completely shaded. So the conclusion doesn't show up. Therefore, any syllogism of the mood AEE and the figure 3 is going to be invalid, regardless of the premises. Let's do it again. Another example, AAA1. All right, so you write out the premises and the conclusion. and now you test it. How do you test it? Once again, you have 3 Venn diagrams, 3 circles overlapped, and you diagram only the premises. Let's start with premise 1. All M are P. You shade logical area 1 in M. Then you diagram the second premise, which is also an A form. All S are M. And now you have to ask yourself whether the conclusion is diagrammed. Now notice that logical area 1 is shaded, and that's what we're looking for. What we're looking for is something that looks like this. In other words, we're looking for 2 circles overlapping where area 1 is completely shaded, but area 2 is not shaded or is half shaded. All right? If area 2 is completely shaded, then that's not what we're looking for. That's not the conclusion, all SRP. If it's half shaded, that's fine, because I can still say that all S are P. Why? Because this portion of area 2 is empty. Therefore, any AAA1 syllogism is by definition valid. Let's look at another example. We have EEA1. So let's diagram the first premise, no M are P. And the second premise, no S are M. Now, the question is the conclusion diagrammed? All S are P. No, because in order for the conclusion to be diagrammed, all this blank portion here would have to be shaded. But it is not shaded as a result. And you can't just shade it arbitrarily at the end. No, it has to be shaded as a result of my diagramming the premises. So it doesn't work. So EEA1 is invalid, always. Another example. AII3. Now, let me take a second to explain a rule. In this case, we have AII3. So the first premise is a universal statement. But suppose that I had an IAI3. What do? In that case, I am allowed to diagram the universal premise first and then go back to my particular premise. Why is that? Well, when you think about it, if I start by diagramming a particular statement, the problem is that I have a blank diagram here. I have 3 circles, and I have to place an X. But where am I going to place the X? If I start, for example, from some M or S, I know that I need to place an X between S and M. But as you can see there are 2 possible places, one here and one there. Now you might be thinking, well, what's the problem? Well, the problem is that if I place an X right here, in this area here, I also thereby diagram something else. I diagram that some S are not P. And if I put the X over here, right, I also diagram that some P are S. Yes, that's the conclusion. Some S are P, but also I diagram that some S are M. And that's not what I want to diagram. So the problem is that I have to diagram exactly what the premise states, and no more and no less than that. Consequently, it's always best to, it's always required that you start with a universal premise. Now, there's an interesting question here. What if all my statements are particular? What do? Well, if all the premises are particular, then it means that the syllogism is invalid. For that reason, because I can place X's all over the place. So it's by definition invalid. But let's go back to AII3. Diagram the first premise, all M are P. Then the second, some M are S. Now you notice that there's only one place where I can put the X now such that I diagram exactly some S, some M are S. And that place is right there. I cannot put the X here because it's already shaded. So nothing goes there. So I'm obligated to put the X right there between S and M. It's the only place. Okay? And as a result, you further notice that the conclusion happens to be diagrammed as a result. Some S are P. Right? Some S are P. So AII3 is valid, always. Here's another example. OAO3. Remember what I explained before. If the first premise is a particular premise, like in this case, which is an O form, and it requires that you draw an X. The problem is that you don't know where to put the X. Therefore, you are allowed to skip premise 1 and diagram premise 2 first. All M are S. Okay? Now you go back to the first premise that asks for some M are not P. Now, what is the place to put the X? Well, you can place an X right there, okay? In which case, you will have diagrammed some M are not P. But there doesn't seem to be any other place to place an X. For example, you cannot put the X here because this portion here, beyond this line, is no longer M. And what you want to diagram is that all the some M are not P. Okay? So the X must be inside the circle representing M and away from P. And that's exactly the right place and the only place. Now, the question is, by diagramming these two premises, is the conclusion diagrammed as a result? Some S are not P. Well, as you can see, yes, because this portion here is part of S, and the X is exactly where it needs to be, away from P, inside S. So the conclusion is diagrammed as a result. By the way, if you have questions and you don't understand you're having a hard time following what I'm saying, feel free to email me, to text me, to leave a message, and I'll be glad to explain and to clarify these points. All right, now I want to talk about now a special case that in logic is known as conditionally valid syllogism. A syllogism is conditionally valid if you consider the syllogism from the point of view of the traditional interpretation, or rather, I should say, let me give you this example. When a syllogism, and only when a syllogism has universal premises and a particular conclusion, okay? Universal premises and a particular conclusion. Immediately, your alarm should go off when you see universal premises and a particular conclusion. Your alarm should go off and say, wait a minute. Any syllogism that has universal premises and a particular conclusion could potentially be valid under certain conditions. Now, take this example, AAI1, universal premises, particular conclusion. All MRP, all SRM, some SRP. How do you proceed? Now, when you diagram the premises, all MRP and all SRM, you notice that the conclusion is not diagrammed as a result. Consequently, from the perspective of the modern interpretation of logic, an AAI1 syllogism is invalid. Why? Because the conclusion does not show up, is not diagrammed as a result. However, suppose that the terms of my syllogism, S, P, and M, are things that really exist. For example, they are computers, cars, bananas, babies. In such a case, I would have to take into consideration the existential assumption. In other words, I have to diagram the X. But where? Where do I put the X? The rule is the following. Every time you have a syllogism that has universal premises and a particular conclusion, you are allowed to place an X. But where do you put the X? You put the X inside either the subject category or the predicate category or the middle term category. Okay? But you're allowed to put only one X, and the rule says if there are more than one place inside a specific class where you can put the X, then you're not allowed to do it. You are allowed to place an X and leave it there if and only if there's only one place to place it. For example, notice that I can place an X indicating that some entities inside the class of P exist. But where do I place the X? there's one place here, a second place right here, and a third place right here. Therefore, by the rules, I am not allowed to make the existential assumption. What about M? Am I allowed to make an existential assumption for M? Well, no, because there are one place here and another place here, so there's more than one. On the other hand, am I allowed to make an existential assumption for S? Well, as you can see, there's only one place inside the category S where I can put an X, right there in the center. That's the only place left, the only space that belongs to S. Consequently, I can make an existential assumption for S. But now the question is going to be, by making this existential assumption, is the syllogism now a valid syllogism? Well, let's see. I make the existential assumption, and remember that the conclusion is some S are P. And by making this assumption, I diagram the conclusion. Some S are P. So what do we say about this syllogism? We say that the syllogism is invalid from the point of view of the modern interpretation of logic, but we say that it is conditionally valid. And the condition is that the members of the S class exist. So if members of the S class happen to be things that are real, that they exist, I am allowed to make that assumption, and therefore the syllogism is going to be conditionally valid. Another example. Universal premises, particular conclusion. AAO2. All P are M, all S are M, some S are not P. Diagram all P are M, diagram all S are M. The syllogism is invalid because the conclusion is not diagrammed as a result. But, question, am I allowed to make an existential assumption? Yes, but let's see. Am I allowed to make an existential assumption for M? Well, no, because where do I place the X? I can place it here, or here, or here, or here. So there are 4 places, and that means that I cannot make that assumption. Can I make an assumption for S? No, because there are 1 and 2 places where I can place the X. So can I make an assumption, existential assumption for P? No, I cannot make that either, because there will be a place here and a place there. There are 2 places. Therefore, despite the fact that AAO2 has universal premises and a particular conclusion, this syllogism is not valid from the point of view of the modern interpretation, but it's not valid conditionally from the traditional interpretation of logic either. It's just invalid. Another example, EAO4. Once again, we have universal premises and a particular conclusion. let's diagram the premises. No P are M, and all M are S. Again, the conclusion is not diagrammed, as we know, because the conclusion will require an existential assumption. It will require an X. Now, the question is this syllogism conditionally valid? Well, let's see. What if the entities in the S category exist? Can I make an existential assumption? No, because there's more than one place. There are 1, 2, and 3 places. What about P? Can I make an existential assumption? No, because there are 2 places, one here and one here. So what about M? Am I allowed to make an existential assumption for M? Well, only if there's only one place to place the X. And as you can see, there is only one place inside the category M right here. Consequently, EAO is conditionally valid. Okay? So these 2 charts show you the unconditionally valid syllogisms and the conditionally valid syllogisms. As you can see, these are the required conditions. Wonderful. Now, in the following few remaining slides, I am going to teach you how to test Sorites for validity. But first of all, what is a Sorites? By the way, the word Sorites is singular and plural. The plural of Sorites is still Sorites. But what is a Sorites? It is a chain of enthymemes. Do you remember what enthymemes are? Enthymemes are arguments that are missing a statement, either a premise or a conclusion. Now, in this particular case, Sorites are chain of syllogisms that are missing a conclusion. So your job when you test a Sorites is to derive the conclusion. You have to make that inference. You have to find the conclusion. How? By diagramming the premises, you will have to derive the conclusion of the first syllogism, and the conclusion of the first syllogism is going to be the premise of the next syllogism, the first premise of the next syllogism, and so on and on. Now, you can do this, you can use the same technique, the 3-Venn diagram technique, so long as the Sorites is written in standard form. And these are the rules for the Sorites to be in standard form. First of all, each statement must be stated in categorical form, A, E, I, or O. The second rule is that each term occurs twice. The third rule is that the first premise must contain either the subject or the predicate of the conclusion. And the fourth and last rule is that each premise, except for the first one, because it comes first, each premise must share a term with the previous statement. Okay, with the rules in place, now let me give you a simple example of a Sorites which is a 4-statement syllogism. We have all A are B, all B are C, all C are D, all A are D. Notice that this is in standard form because one term of the conclusion, namely term A, is also stated here in the first premise. Notice that each premise shares a term in common, B and B, C and C, D and D. Okay, and notice that all the premises are stated in categorical form, and that there are only 2 terms. I'm sorry, 3 terms. A, B, and C. Okay. So how do we test a Sorites? Same story, we have 3 Venn diagrams, and what's important is that we label the premises. So we label A, B, and C. Now remember that what we're trying to do here is to diagram the premises. But where is the conclusion? Well, the conclusion is an intermediate. It would be right here in between. It would be an intermediate statement that we have to derive by diagramming premise 1 and 2. You always diagram 2 statements. So let's diagram the first one. All A are B. And then the second one, all B are C. Now, here's the tricky part. You have to look at the diagram and you have to derive a conclusion. Or in other words, by looking at this diagram, what conclusion can you draw? As you can see, you can draw the following conclusion, that all A are C. See? All A are C. That's the conclusion that is not stated in the premises, but it's diagrammed as a result. All A are C. Now, this conclusion, all A are C, as I pointed out, becomes the first premise in the next syllogism. So it becomes the first premise, and then number 3 is the second premise, and finally number 4 is the conclusion. So what do we want to do now is to diagram again the next set of premises, all A are C and all C are D, and see what happens. We already have all A are C, and now we have to diagram all C are D. Now, once again, we look at the diagram, and what can you see? What conclusion can we draw? Well, clearly, we could draw this conclusion that all A are D. Now, that happens to be our conclusion. All A are D. Consequently, I know that this Sorites is valid. Now let me give you an example of a 5-statement syllogism. 5-statement Sorites. Once again, we proceed in the same fashion. We diagram premise 1 and premise 2. All M are P and no J are P. What conclusion can we derive from these 2 premises? Well, clearly the conclusion is that no M are J or no J are M. See, no M are J. Now, no M are J is going to be the conclusion of the first syllogism that we derived from diagramming the 2 premises. and it becomes the first premise of the next syllogism. So we need, again, 3 more circles. So we have no MRJ, which is diagrammed as such. And we have to diagram now all HRJ, which we diagram this way. Now, what conclusion can we derive from this diagram? Well, clearly, we can derive the conclusion that no M are H. Once again, the conclusion no M are H becomes the first premise of the last syllogism. No M are H, which is already diagrammed right here, and all C are H, which I diagram as such. Once again, the question is, what can we derive? What conclusion can we derive from this diagram? Well, we can derive the conclusion that no M are C, as you can see. And that conclusion happens to be our conclusion. No M are C. Consequently, this Sorites is also valid. Well, that's all for now. I hope you enjoyed the video. I hope it was useful to you. Once again, feel free to ask me any questions. Either you email me or you leave a comment under this video. I'll be glad to explain, to clarify any questions you might have. Till next time, have a great day, and I'll see you soon.